In the name of Allah, the most beneficent and the most merciful. Assalamu alaikum, all of you. How are you, dear students? I hope you all are doing well. Dear students, this is Pakistan International School Thai's virtual learning class for subject Science for grade 6. Today's lecture number is 18 and we are studying chapter number 7, Solutions and Suspensions. Dear students, today we are going to see our last two topics, solubility, and we will see suspensions and its uses in our daily life. Dear students, in the previous topic, we have studied about solute, solvent, and solutions, some different types of solutions, and we have studied different uses of the solution in our daily life. Then we have seen how the water is said to be the universal solvent, as well as we have seen about saturated and unsaturated solution, dilute and concentrated solution. Today we will see solubility. Solubility means actually that comes from the word soluble, means to be dissolved. So solubility is actually the ability of a substance, like a property of a substance or solid, liquid or gas substance to be dissolved in any type of solvent. So chemically, it's like if we define the solubility, so the amount of solute in grams, which is dissolved in 100 grams of the solvent. But what is the condition? At given temperature. The temperature must not be increased or decreased. At the specific temperature, it has to be dissolved. How much quantity of the solute will be dissolved, but the quantity can be measured in grams or any other numbers, and it is dissolved in 100 grams of solvent. We will see here that how different different substances, solid, liquid or gas, or we can say the solute, will be dissolved in the solvent, and how the solubility is affected by the temperature if we increase or decrease. So how much quantity of the solute is dissolved in water or in any other solvent, that is actually called solubility. So if we explain it, you can see there are examples and the differences between two substances. 24 grams of crystals of blue copper sulfate in 100 grams of water is dissolved at room temperature to make the saturated solution. We have seen before saturated solution? Yes. So the quantity of a substance which is dissolved into the substance a given temperature, after that no other amount can be dissolved and it will settle down. Up to that point, that is called saturated solution. So to make a saturated solution, that means that all the solute particles will be dissolved in the solvent. That is called solubility of that substance. So for copper sulfate, that color is blue. So blue copper sulfate is having the solubility 24 grams per 100 grams of water. So we'll write it 24 grams per 100 grams of solvent. If we compare the other solid solute, that is sodium chloride, or that is called the salt, common salt, that is having 36 gram of table salt. Look, compare both of them. Here is 24 gram, like less amount of copper sulfate can be dissolved in the same quantity of water. Here 36 grams of table salt can be dissolved in 100 grams of water at the room temperature. So how this is the difference? This is according to the strength of the substance to be dissolved in a solvent. So if we just perform an experiment that take 100 gram of water in a beaker and make a saturated solution of sodium chloride, like we have seen before. So how much will it take? 36 gram. Yes, at the room temperature. So start heating and heating it. So what will happen? Before heating, that was saturated solution at room temperature, but now when we increase the heat of the solution, so what will happen? More salt will be added to make the saturated solution on that specific temperature. It means that when we increase the temperature, solubility of the solute will be increasing. Yes, so more solute will be dissolved in that substance, in the solvent. We can see here copper sulfate can be, its solubility will be increased by mixing and by heating. When we mix the substance, they will dissolve more quantity, as well as when we heat the substance, the solution, so it will dissolve more quantity of solute. So we can perform the experiment in the lab like this. We just hang a thermometer over there to control its temperature. There is a burner, and as well as we are going to dissolve some solute in the water, and we are going to make a solution. So now we are at the result that 24 grams of copper sulfate dissolved in 100 gram of water, but at room temperature, that is 25 degrees centigrade. So but when we increase the temperature, so at 60 degrees centigrade, 60 grams of copper sulfate will be dissolved. So it means 24 to 60 gram. It means that solubility of that solute will be increased, means we can add more solute to the water to make the solution when we increase the temperature. Yes, so we can say that solubility of copper sulfate is 24 grams at 25 degree centigrade and 60 grams at 60 degree centigrade. Okay, so now we will see the effects of temperature on the solubility. So number 1 point is solubility of a solid solute increases with increase in temperature. As we have seen before, that we add more solid solute in the solvent when we increase the temperature. So it means solubility of the solid solute, or we can say that liquid solute as well, that will be increased by increasing the temperature. And if we see the next point, that solubility of gases, that is another different issue, that gases are not dissolved more when we increase the temperature. Rather than they leave this place when they get more temperature, so they do not dissolve actually in the liquid solvents, and decreases with increasing the temperature. So you can take here the example of carbonated drinks. Like gases in the liquid solvents, their solubility decrease when we increase the temperature. So before drinking them, we just keep them in the refrigerator to make them cold, so that they must be dissolved properly and they give us good flavor. So here we can see that if we just make a graph of solubility and temperature, so we can see that solubility of solids and liquids will be increased by increasing temperature, like increasing by increasing temperature as well. And here solubility of gases will be decreased with increasing temperature. So right now you'll see some solutions and their uses. Like we can see carbonated water. This is very common example that carbon dioxide gas is dissolved in water. When we shake it, so what happened? The gas separates quickly from the water and it splashes out of the bottle. Sometimes the bottles burst, due to the pressure. So in a closed can, bubbling gas has no place to go. It builds up pressure. When we open, the gas escapes. Number two, we are having example, we use lemonade and tea as well in our homes. Different type of squashes, sherbets, they all are examples of solutions. Next is, in the air is the solution of different gases. We breathe in the solution, yes. We breathe in nitrogen, carbon dioxide, and all the oxygen as well, all the gases which are present in the air. But our body needs only oxygen, so we consume only oxygen and all other gases will exhale out again. If we see the next one, the steel used for buildings and cars is a solution, and we know that that is an alloy, and that is the mixture or the solution of two or more metals. During the process of steel, carbon and iron, they are melted down into the liquid form and the carbon is dissolved in iron. So both are mixed together. Then we are having this type of a steel. The next one, ocean. Lots of time we have discussed that that is the largest reserve, or we can say a solution, the biggest solution in the world. And we are having lots of minerals, salts, as well as gases dissolved in water, oxygen and carbon dioxide, which is used by the living organisms under the water for their life. Yes, my dear, that is the last but not the least, suspension. We have seen that mixture is of two types, homogeneous and heterogeneous mixture. Homo means all its structure and form is same. Hetero means the form of the solution is different. So you can see here this example. So a mixture in which solute particles are too large to move freely with the solvent particles. So what happened? Then these particles settled down at the bottom. This is called suspension. Suspensions means the the hanging material, the spread material, they are just moving around or sometimes settle down when we just keep that solution at a side for some time. So all, because the particles are so big, so they are heavy as well, so they cannot be mixed with the solvent, especially with water and other liquid solvents. So they start to settle down because they are heavier than water, and larger as well. So this is an example of chalk. We are dissolving chalk in the water. So what happened after stirring it? After stirring it, that becomes milky, but when we keep it aside for some time, so water is clear here and all the particles settles down. You can see here. So the particles are bigger in the solution, or in we can say suspension, so we can separate that out easily by simple filtration process. Like this is a very good example of tea, which we use at home. So when we filter that by a strainer, so what happened? Tea leaves just stay outside like this on the strainer, and we are having clean tea, liquid tea in the cup. Like this process we have studied before in the previous chapter, that is called filtration. And by filtration, what happened? The sand, if we dissolve sand in the water, so we can just separate that sand, and that is just that left on the filter paper, and all the like filtrate just passes down into the container. Dear students, we are having lots of examples from our daily life regarding suspensions. So, like when we mix soil in water, so that is also suspension. Sand or soil we mix in the water. So after some time, just clear water just remains up, and all this particles, because they are big, so they just leave down. Lassi is a form of suspension that is also called laban in Arabic, or sour milk in English. So that is commonly used in summer especially. So that is also the suspension, because that is having big particles of yogurt. So just they when you just keep this glass for a short period of time at a side on the table, so what will happen? The water will come up, and all the particles that will settle down. Fruit squashes are the examples of suspensions, that they are thick, concentrated, and the like especially the pulps, and the squashes which are made by the fruits, they are having big particles and like big portions of the fruit, so they uh, are found in the form of suspension. There is another example, common example is that what happened, that in the rivers, especially rivers and canals and lakes, the water which you can see, like this is like this, the muddy water, because mud is mixed in that. So while stirring up, while floods, and while the moving of this flowing of the river, just they appear like a solution. But what happened when they are stagnant? So after some time, sand and soil settled again at the bottom. Dear student, very common example in our body, that is the blood. Blood is also a suspension, although you cannot see, but you can see from here the microscopic clear image of the blood flowing into the artery. So blood in the blood vessels. So you can see here that in the blood there are red blood cells, white blood cells, and platelets, which we have studied in chapter number 1 about these things. So they are suspended, and look, they move in the solution form. That's why they are called suspension. You can see these are red blood cells, which are bigger. The white spots, you can see they are like white blood cells and platelets as well. So they are suspended in the form, like in the solution. That solution is called plasma. So we can, like in the lab when we are having blood tests, so we can separate blood cells and all these stuff like white blood cells and platelets from the plasma, and we can separate out plasma like a fluid of the blood in which these things just float. Dear students, we are having a very common example also that is used for the construction purpose, that is a slurry formation. What happened when there are large amount of insoluble solid particles, large amount of solid particles, and in that the water or solvent is very less, so the runny paste is formed. That is called slurry, and that can be we can have the cement example for that, which is mixed with the water to earn some concrete, some stone pieces that is used for construction purpose. We can also have like slurry like appearance which you can make from corn flour. We can like see these type of things in our daily life. Okay, there are very some common examples also which we see in our daily life, that is uh, uh, this medicines. These medicines are just in the powder form, and when we make, like especially antibiotics, and we mixed water inside it, and just after some time when we want to use it or give to the patient, so we have to shake it again. That is due to that, because the medicine which was in the powder form, that is having the big particles, and it will settle down after some time, and if we don't shake it, so just it means we are giving just water to the patient. There is no medicine, because medicine is settled down, so we have to shake every time. Yes, we are having another example in the ponds, in the lakes. Sometimes we'll find this green type, green form of water, and this water actually is green due to the presence of algae. If you see in the bottle, there algae is collected, like the water is collected, it's a green color, but actually this green color is due to the presence of algae. Algae, sometimes that is microscopic and sometimes that is bigger, like macroscopic, multicellular, but here it is unicellular. So it is collected in the water and it makes the water suspension, like it's floating, it is suspended in the water. So sometimes it is the food of small fishes and other aquatic organisms, but sometimes it is very harmful. It is if it covers whole of the area. So that can be dangerous also. Okay, dear students, so now we will compare some properties of solutions and suspensions in this topic. Yes, if you see number one, that in solutions, particles of solute do not settle out. If you see in this, this is solution and this is suspension. You can see solute particles are completely dissolved and they are not settled out. But here in the suspension, particles are settled out because they are larger in size. Number two, particles pass through ordinary filter paper. And in suspension, particles can be separated by ordinary filter paper. Like we have example of sand in the water and uh, a tea solution. So in suspension, what happened? We can filter them out, and these sand particles and tea particles, they can uh, they can be left outside on the filter paper. But here in the solution, because particles are not to be seen visible easily because they are completely dissolved in the liquid, so they can pass through the filter paper and they are not just left on the filter paper. Okay, the next one is light rays do not scatter on passing through the solution. How it is happened? That how in the solution light rays do not scatter. Scatter means to spread, because that is clear. When we add, for example, salt in water, so what happened? That makes the clear solution, as well as in sugar solution. So the solution is clear and all the particles, because solid particles are smaller enough so they can dissolve properly in the solvent. So how the light rays do not scatter? Now we'll see when the light rays pass through it, so they just travel straight and just go through another place on the other side. So we can see, because the water is like the transparent substance, so we can see through the other side, and the light rays just go straight, they are not scattered. But what happened in suspension? When the light passes through this suspension, because for example the sand, so because the particles are bigger, so light strike to this particle and then it moves to the other side like a refract, and then it moves to the other and just strike over there, then strike over there, then strike over there with the other particle. And because the particles are bigger, so the light rays spread all around. So because it cannot pass through in a like in a line in a proper way, so we cannot see on the other side, because when it spreads all around, so it can change its direction. So light rays scatter on passing through suspension. Sometimes it just strike like this, like this, like this, and just go out, so we cannot see on the other side. Because the particles are bigger, so light rays scatter. And in this solution, light rays do not scatter because the particles are smaller. My dear students, with this topic, we have completed our chapter number 7 and our first term, Alhamdulillah. Now just take a look of this chapter number 7. Just for a review, that in this chapter we have studied about homogeneous and heterogeneous mixtures. Homogeneous mixture of 2 or more components, and that is a solution. Then we have seen aqueous solution, in which water is a solvent. Then we have seen water is a universal solvent, and lots of examples. Then we have seen the solution types: concentrated solution, in which more quantity of solute is dissolved, and if less quantity of solute is dissolved, that is called dilute solution. Then we have seen that there are saturated solutions in which no more solute can be dissolved at given temperature. Today we have seen solubility, that how much quantity of solute can be dissolved in a substance, as well as we have seen solutions and suspensions, their differences and the uses and daily life examples of suspensions as well. So with that, my dear students, we have finished all our chapter number 7. So you have to revise all your syllabus, all your chapters, and you have to manage your time accordingly to just keep them revising again and again, so that your concepts must be stronger enough. Dear students, you must take care of yourself and your family. Keep healthy and stay safe. Wish you all the best.